So we were actually discussing the important trends and anomalous properties of boron. Certain important trends can be observed in the chemical behavior of the group 13 elements, right? So what we are actually observing, the trichlorides, the bromides and iodides of all these elements are covalent in nature. The trichlorides are covalent in nature, okay? The bromides are covalent in nature, the iodides are covalent in nature, and they are easily hydrolyzed in water. Species like tetrahedral MOH4 minus and octahedral MH2O6 3 plus, except in boron, exist in aqueous medium. Okay, so their halides are basically, for example, boron halides BCl3, BCl3, these tetrachlorides, and as well as iodides or bromides, for example, right? So these kind of things that we are given, okay, right? So these kind of things actually they are covalent, largely covalent in nature. First of all, they are telling this. Secondly, what they are telling is that they are easily hydrolyzed in water. So for example, if they react in water, so they form this BOH4 whole 4 minus, right, after being hydrolyzed in the water. Or aluminium, if it reacts in water, it would rather form Al H2O6 whole 6 3 plus, right? So these ions would be formed. This is octahedral, this is like tetrahedral, right? So these kind of things are going on. All right. So the next topic that is the monomeric trihalides being electron deficient are strong Lewis acids. Okay, so these are strong Lewis acids. What? Monomeric, which one we are talking about? The monomeric trihalides. Monomeric trihalides like BF3 basically, right? So they have actually only 6 electrons. If you see, like BF3 is, okay, in this bonding only 6 electrons are there now after sharing of electrons. Okay, so this is basically deficient in electrons or not? Deficient in electrons. It can accept the lone pair of electrons, so it is a Lewis acid, right? So it is a Lewis acid, right? Okay, all right. So the monomeric trihalides being electron deficient and strong Lewis acids, boron trifluoride easily accepts NH3 to form a complete octet. What does it do? This BF3, which is which requires a lone pair of electron, which is a good Lewis acid, and has only 6 electron in the outermost shell right now. It can accept a lone pair of electrons from NH3. NH3 will give the lone pair of electrons and participate as a covalent bond, so it will form like BF3. It will form like B, right? One thing will be out of the page, one thing will be into the page, okay, into the page, and one thing will be like this, and this NH3 will be giving lone pair of electrons to boron, and the remaining 3 chlorine atoms chloride will be like this. So it will become from planar, BF3 is planar, from planar it has become tetrahedral. All right, so this is it. Now what does it do? It is due to the absence of d orbitals that the maximum covalency of boron is 4. So can boron take further electrons or can accommodate more electrons? No, no, because boron's electronic configuration is 1s2, 2s2, 2p1. So it has no vacant 3d orbitals. So it cannot accumulate extra electrons and it cannot form any bond more than 4. So its coordination number cannot be more than 4. Alright. Since the orbitals are available with aluminium and other elements, the maximum covalence can be expected beyond 4. So now in case of aluminium and other higher metals, aluminium is 1s2, 2s2, 2p6, 3s2, 3p1, and the d orbitals are vacant. 3d orbitals are vacant in aluminium. Since they are vacant, it has a tendency to accept extra electrons and form the excess bonds. So aluminium does form excess bonds. For example, right? So for example, we were talking about that octahedral Al aluminium H2O whole 6 3 plus this ion. This was an octahedral shape, so its coordination number here was plus 6. Now what is it telling? Most of the other metals are dimerized through the halogen bridging. Okay, the metal species completes its octet. So most of the other metal halides, right, excluding this boron trichloride, excluding this boron trichloride, others like AlCl3, what does it do? As we have discussed actually, what does AlCl3 do? Right, we have for example this chlorine, we have this chlorine, we have this chlorine, and we have this chlorine. So what does it do actually? What does Al do? Al participates in the reaction. This chlorine goes to, for example, C. We have this AlCl3, 3 chlorines are there, alright, and here also 3 chlorines are there. For example, if we consider, right, 3 chlorines here, right. So what will this chlorine this chlorine do? This will give to this, okay, and this chlorine will give to this, for example, and it forms a dimer sort of. Okay. Sorry, we actually missed. For example, this chlorine will give to, for example, this one, and so it forms a dimer sort of a thing. For example, if we can see in this case, we have drawn in the previous cases. See, this will show you like this. This was AlCl3 before any bonding, 2 AlCl3 molecules. Then this chlorine gives lone pair of electrons to this, and this chlorine gives to this, and it forms a dimer. Similarly, other elements like of this group 13 can also form the dimers. Example, gallium chloride, indium chloride, and thallium chloride. This can also form a dimer. Right. The metal species completes its octet by accepting electrons from the halogens in these halogen bridged molecules. Okay, so what does it do? It accepts the electrons like this, as it was given. It accepts electrons, right, and it completes the octet. So there is one lone pair of electron, it will accept that, and there is one lone pair of electron, it will accept that, and it will form a bridged molecule. So boron is unstable to form BF6 3 minus ion. See, this type of BF6 3 minus ion octahedral, this thing is not possible. Okay, this thing is not possible. For example, there are 3 F minus, okay, and BF, this is BF6 3 minus. This is not possible. Why? Because there is no vacant d orbital. Right. So this is very important, extremely important from this point of view. The metal species completes its octet by accepting the electrons from the halogens in the halogen bridged molecules. Alright. Okay. So now why this BF6 3 minus is not possible? Due to non-availability of d orbitals. Boron is unable to expand the octet beyond 4. So the maximum covalency remains 4. Right. Now let us proceed. Some important compounds of boron. As we told that there are the borax is not in the syllabus, orthoboric acid is not in the syllabus, right? The diboron is not in the syllabus, related to this question is not in the syllabus, and this is also not in the syllabus. Uses of aluminium is also not in the syllabus. So what is in the syllabus? Basically the uses of boron and aluminium and their compounds. So boron being extremely hard refractory solid of high melting point, low density and very low electrical conductivity. So it has two three properties. Okay, high melting point and very low electrical conductivity. It finds many applications, like boron fibers are used in making bulletproof vests, and these are lightweight and strong. So the boron 10, this isotope of boron, it has high ability to absorb the neutrons, hence it can be used in the nuclear reactors to absorb the neutrons. Hence therefore the metal borides are used in nuclear industry as protective shields and control rods. The main industrial application of borax and boric acid is basically the manufacture of heat resistant glasses like Pyrex. So this borax and boric acid, which are the compounds of boron, basically these are used to make what? These are used to make heat resistant glasses like Pyrex and glass wool and fiberglass. Borax is also used as a flux for soldering metals. Now soldering, what does soldering mean? Actually joining the two metal parts, like welding we saw. Welding, in welding also the two parts are joined together. In soldering also, what does it do? That for example, there is a metal thing and there is a flux. So by the use of soldering, this flux gets permanently sticked onto the surface of the metal, and it gets sticked. So this is known as a solder. This is known as soldering process. This is used in the manufacturing of chips. What chips? Microchips. Okay, all right, the small semiconductor devices. Okay, these kind of things are used. So for heat, scratch and stain resistant glazed coating earthenwares and constituent of medical shops soaps. Okay, so these are some other applications. An aqueous solution of orthoboric acid is also used as mild antiseptic. You can also remember this. This is also a good question, that orthoboric acid basically can use as a mild antiseptic. Okay, H3BO3 can be used as mild antiseptic. So this was all about group 13 elements. Further we will be studying about group 14 elements, the basics of group 14 elements. Then we'll be talking about their covalent radius, electronic configuration, ionization enthalpy, electronegativity and the physical properties. After which we'll be talking about the chemical properties of the group 14 elements and some important allotropes of carbon. That's it. So we'll proceed with the group 14 elements in the next class.